Hi everyone, welcome back to another video. So in this video I'm going to be going over how my first lecture and tutorial went for my instrumentation and control module. It's a bit weird how they're doing it this year. I was supposed to study analog electronics prior to studying instrumentation and control, which kind of makes sense if you know anything about those modules. My year is divided into 3 teaching blocks, beginning being instrumentation and control and principles 2, then after analog electronics communication systems, then after that embedded systems and engine design project 2. The good thing is that the last 2 modules, Embedded Systems and Design Project 2, are both like C programming, so I shouldn't have any problems with them at all. And they're both practical based, with you get like bits of kit. That's going to be super easy. But what is a big pain in the backside is instrumentation and control. So for whatever reason, they've put it prior to analog electronics, which is crazy. Like, you're supposed to learn about analog electronics and resistors and stuff before you do instrumentation and control. So I've now ended up basically in my first lecture going into op amps, operational amplifiers, and even just looking at that, like, I don't like, fine, I kind of get that there's a plus and minus, inverting and non-inverting input, and there's a supply positive and negative, and then the voltage out. But as for understanding like what an op amp does, I don't get it at all. And I watched a 20-minute lecture on it, and didn't learn anything. And then I sat in the tutorial and I made all of these notes. The notes that I made on it are actually quite good. And the way that I learn, if you've watched my videos, you should know by now, is I make questions for myself so that I can actually start to memorize what it is. And I also don't like to just do the work that they're giving me without understanding what it is. And so one of the more frustrating things about this is that I could technically go and do all of the assignments without learning what an op amp really is, and I'd probably still get 60-70%. And so it would be more than enough for me to get a first. But I actually do want to be a decent electrical engineer, so I actually have to learn this stuff. So it's frustrating, is what it is. But I'm going to take you on this journey with me, and hopefully in this video I'll just go through basically what an op amp is. We can go through it together. Hopefully you learn whilst I learn. That's the plan. So I'm actually on holiday at the moment and I don't have any Wi-Fi, so I'm going to be learning from a book, a PDF that I've got on my Dropbox. So it's all good. Let's just get that PDF now. So I've got the 3rd edition, but we'll use the 4th edition because now ideally, I haven't done this, but ideally I should go through the whole book. But I'm just going to skip to operational amplifiers for now because I'm going to try and hopefully learn as much of it as I can without doing the whole book. Me personally, whenever I listen to lectures, I usually in a lecture I can understand 50% of it, but in this one on operational amplifiers, and it was close to 5% probably. Okay, so I've taken some notes in my tutorial that I had this week. I basically, instead of doing the tutorial which she wanted me to do, which was a multi-sim tutorial, instead of doing that, I just took notes on what an op amp was, and I spent a whole bunch of time on Google looking around and searching, finding stuff. So I made all of these notes. So let's just quickly, I'm going to whiz through these notes as a way of revising, and then hopefully I'll try and build on top of it. But like I said, I've got no internet at the moment, so I'll be limited to what I can learn from the book, but it's fine. Hopefully the book will be good enough. So basic op amp schematic, I'm okay with that. Voltage supply plus, minus, V out, and then you've got the non-inverting input, which is this V plus, and the inverting input, which is V minus. Okay. Then you got a 741 ICP, integrated circuit package. So I don't know what offset null and not connected and offset null means. Get that, but I know I've got the negative power there. I've got the positive power there, and then 2 and 3 are the 2 inputs, 6 being the output. So in terms of using an IC, if you said to me this is a 741 op amp, I could work with that. I'm okay with that. So what does an op amp do? Let's test myself. An op amp, a basic explanation of an op amp is that it amplifies voltage signals. Yeah. Okay, so what I do now is I mark that in a color and I do it red. So red means I don't know it basically means. So I'll start off marking it as red, and then when I ask myself again tomorrow or next week, then I'll mark it as orange, then yellow, then green, then blue. and blue means I fully know it. So what does an op amp actually do? Like an actual definition beyond amplifying signals, it amplifies the difference between the two inputs. Amplifies the difference between signals and yep. I don't really get that, but I get the answer. I've memorized the answer, but I don't get that. I don't get that it amplifies the difference between it. So meaning if you had here, or if you had here at the non-inverting input, you had 6 volts, and the inverting input, does that mean that it inverts the 6 volts? Or I don't know. I think like it's not like anyone's taught me how it actually, I don't get actually how these two inputs work. So is the non-inverting inputs, if that was 6 volts, is the inverting input minus 6 volts? I don't know. Or can that be a different thing? Can the non-inverting input be 6 and the inverting input be 4? Is that possible? Huh? Let's say the first is the case, 6 volts here and minus 6 volts here. And that would mean that you've got 12 volts between them. Okay, and then it amplifies that 12 volts to its output. But I know here it can only output a maximum of 85% here, 5%. The output cannot be more than 85% of supply voltage. Okay, so that's to do with the supply voltage, not inputs. You see, I'm already stuck. Like just as I'm talking to you now, I realize I don't even get how these inputs work. Can I stick any signal onto there? Okay, let's just move on anyways. So the op amp construction is inputs. It's got inverting and non-inverting. Yep. And then it's got supply voltage, positive and negative. Yep. Got an output, V out. Yep. Okay. Now here's where we get tricky. Saturation. I'm gonna remove this. Oh, this is not that helpful. I've got it up there. I'm okay with it. Okay, so saturation is a bit tricky. So if the non-inverting input, if one of the inputs is higher than the other, then the op amp will try to get it to be the same. So try to remove the difference between them. It'll take the one that's more positive. So if you've got 6 volts and minus 6 volts, it'll take the more positive one, try to bring it down to the less positive one. Yeah, I don't know. Let's have a look. So if the voltage on one of the terminals is more positive than the other, the output goes to the opposite supply voltage, either negative or positive. If the output on one of the terminals is more positive than the other, okay, the output goes to the opposite supply voltage, either negative or positive. You got a voltage, let's say you got voltage in, coming in here, and it's more positive than voltage out, then V in will come down to here. So where are we getting V ref from? Where's this reference voltage coming from? So it says here, if V in is greater than voltage reference, what's the reference? The ground? Oh, no. They said that they've got reference voltage. Where did that come from? Okay. Then V out is equal to plus VCC. Otherwise, it's mine. I don't understand that again. I'm telling you, there's in order for me to be able to understand this, there's surely a lot that I need to know before. Like we're talking about in this book, it's chapter 8. Like, let's see what chapter 1 is on. Entertain me here, yeah. Chapter 1 is on introduction. Chapter 2 is theory. Chapter 3 is basic circuit components. Chapter 4 is semiconductors. Let's see semiconductors. I don't know anything about transistors, diodes, microchips, solar cells. Okay, chapter 5, optoelectronics. On amps, solar cells, sensors, hands-on electronics. Boom, we're onto operation amp. Yeah, man. Okay, is what it is. All right, and then I already know max output is maximum 85% high voltage. Mark that as red. And the saturation, I didn't really get it right, so leave that as is. But yeah, I'm not really comfortable with that at all. If after this video I still don't really get it, then I'm just gonna spend like the next 4 days going through the book or any book that matter and trying to learn analog electronics on my own, which is crazy because that's a whole module. And yeah, I'm just gonna have to try and whiz through it in a few days, which is again a bit mad. This is what the current health situation in our world does to you. Okay, so same voltage on both inputs. Oh wait, crap! I clicked on it. But so what's this trying to tell me? Same voltage on both inputs. Both inputs have the same voltage. This is not a question, so I don't really get it. Both inputs on same voltage. Okay, we just have to read it. I don't know. If the same voltage potential is applied to both terminals, the result output will be 0. Okay, let's do this. What happens if both inputs have same voltage? There we go. If the same voltage potential is applied to both terminals, the resulting output will be 0. So does that mean in my example of 6 volts and minus 6 volts, the output will be 0? An operational amplifier only responds to the difference between the voltages on its two inputs. Excuse me. Known commonly as a differential input voltage, not to their common potential. Okay, I get that. I get that. If okay, that's obviously makes sense. If the voltage is the same, then you're not amplifying anything. The output is 0. Okay, wait, 0. So it just sinks it to ground. But I still don't understand how you're adding, what you're adding to these two inputs. Okay, so we've got 2 golden rules. I kind of remember these. The golden rule for difference is that the operational amplifier always seeks to remove the difference between the two. The output tries to make the voltage difference between the two inputs 0. Yeah, okay. Got that. And current is that ideally, in an ideal op amp, it doesn't draw any current. Ideally, it draws no current. Okay, sorted. Then there's a whole bunch of assumptions that we make. Yeah, these assumptions are long. Let's see if I can remember them. There's one about input impedance and output impedance. There's one about the power supply rejection ratio. There's one about the common node rejection ratio, and first one at the top, I can't really remember it right now. It is also there's also no noise. The first assumption is that the open loop gain is infinite. There you go, boom. Open loop gain, input impedance, output impedance, noise, common mode rejection ratio, and power supply rejection. Look at that. So in one sitting, which was in my lecture, I've managed to memorize at least the assumptions or what their names are. I remember that this is open loop gain has to be infinite. I remember that. As for input impedance, it has to be one of these has to be 0 and the other one has to be infinite. So I think input impedance has to be infinite. Yep. And output impedance has to be 0. Yep. Noise, we assume that there's no noise. And then common mode rejection ratio, we assume that, I don't know. I know what common mode rejection ratio is since I last did it, but I don't know what we assume about it. Okay, so common mode rejection ratio is infinite. I don't really know what that means. How can a ratio be infinite? Does that mean 1 to infinity? You put a pound in and you get an infinite amount of pounds back. Yeah, I don't get it. And then power supply rejection ratio, I assume, is going to be infinite as well. So I'm comfortable with all of these in the sense that like I know them, but really in reality I don't really know, especially because I don't know how to do this. But okay, so in terms of what is open loop gain? What is open loop gain? The open loop gain of an amplifier is the gain obtained when no overall feedback is used in the circuit. The open loop gain, right? So in terms of the gain of the amplifier, right? How much or what is the gain? So the open loop gain of an amplifier is the gain when no feedback is used in. Okay. I don't get how that can be infinite as well, but I'm gonna take it on the chin because I don't want to just. I spent about half an hour looking at open loop gain and I didn't really get anywhere. Input impedance. I now know that impedance is like resistance of a circuit, but it includes inductors and capacitors as well as impedance. Simple Z is a measure of the overall position of a circuit to a current, how much the circuit impedes the flow of charge. It's similar to resistance, but it also takes into account the effects of capacitance and inductance. Impedance is measured. Yep, okay, so I'm okay with that. What does it mean that the infinite impedance is infinite? So input impedance is, so if you have an impedance, oh, I get it, because obviously you don't want the op amp to draw any current. So what you want is you want a basic, stupidly high infinite resistance in these wires such that no current goes into them. You just want to apply a voltage across them. Ah, I get it. Couldn't someone have explained it like that? Like, come on, man. Explain it like you're explaining it to a monkey. What I read online was just a joke. Okay, so infinite impedance is input impedance is infinite. Um we want the inputs to draw no current. That's cool. I'm okay with that, actually. Very happy with that. Okay, and so we want the output impedance to be 0, right? I don't get why we want that to be 0, because we don't want any current flowing, right? Is that we don't want any current? Yeah, it draws no current. So if it draws no current, I mean that there's no current in the output. So why would we want it to be 0? Why do we want the output impedance? Why do we want the input impedance to be okay. Alright, so I'm actually, I must say, there's this thing of like, when you talk to yourself, it's like you're explaining it to yourself and you're putting your ideas out there, and then you're giving your ideas a chance to make sense to you. That's kind of what's happening to me now. So even as I'm reading this, it's the day after I have my lecture, so it's actually starting to make sense now. When I was doing this, I was like, I'm not getting this. I'm writing it down, but I don't get it. Okay, so we want no noise in the circuit. I mean, of course, you don't want noise in your circuit ever, so that's okay. And then common mode rejection ratio, you want it to be infinite. I don't get why you want it to be infinite, but I have a decent idea of what common mode rejection is. Alright, so common mode signals are when the same signals are applied to the input. Identical signals applied to both the inverted and non-inverted input. Boom. And common mode rejection is when the op amp rejects, or when the output doesn't change when two of the identical signals are placed upon the inputs. The ability to eliminate the common mode voltage from the output. If an identical signal is applied to both the inverted and non-inverted inputs, there should be no change to the output. Booyah! Got it right as well. Love it. Love it. Love it. Okay. Again, I'm okay with that. And then what is the common mode rejection ratio? So the common mode rejection ratio, I'm trying to do it from my head here, is the ratio to which the inputs, the two of the same inputs, affect the outputs. That was a guess. In real amplifiers, there's always some variation between the common mode input and output. There's always some variation between the common mode input and output. There's some variation. Okay, so there's some change between the input. Don't get it. Okay, this ratio is called the common mode rejection ratio, CMRR, i.e., 1 volt in and 1 volt out is equal to 1-to-1 ratio, which is equal to perfect. This was what I wrote down yesterday, but I don't know if that's true. I didn't get it from anywhere, so I'm gonna delete it. Don't take my word for that. Pretend you never saw that. Okay, and finally, I didn't do well on from my rejection. That. And power supply rejection ratio. Let's just pop this in here. We want it to be infinite. Why do we want it to be infinite? And what it is? I don't know. Yeah. So that's where I'm at right now. Whoops, oh dear, I've put power supply rejection part of. Yeah, there you go. Input impedance, open loop gain. All right. So I feel a bit better about that, to be honest. Too. Okay, so let's jump into the book now, and I'll start making my way through the chapters, and then hopefully add to the Notion notes. Yeah, man. Hopefully, by the end of this video, we will have a decent understanding of op amps, at least better than what I've had so far. And I do actually feel like I'm getting there. So I didn't actually realize that I'm 25 minutes into this vid, so I'm gonna finish this one here and then start from the next video, start going through the book. It's just easier that way because uploading and all that becomes a mess. So yeah, I will continue with this in the next video.